Extraordinary responsibility that was on our shoulders to carry out the mission correctly as the second human to set foot on the moon during the historic Apollo 11. Mission Buzz Aldrin's silence about his lunar experience has long intrigued the world. However, recent admissions by Aldrin have ignited a storm of speculation and curiosity. What did Aldrin witness on the lunar surface? And how could this change our approach to lunar exploration? Join us as we delve into Buzz Aldrin's revelations and explore the implications of his long-awaited music confessions. The moon was the last big goal in the space race between the USA and the Soviet Union. It started when the Soviets launched Sputnik, one the first artificial satellite into space around Earth, on October 4, 1957. This surprised the United States and made them worried about Soviet technology being better. So the United States started doing more space exploration through NASA. Then the Soviets did it again by sending Yuri Gagarin into space on April 12, 1961 in Vostok 1. Gagarin became the first person to circle Earth in space in response. U.S. President John F. Kennedy said they would land an American astronaut on the moon and bring them back safely before the end of the 1960s. This started the Apollo program. The big moment of this race was the successful Apollo 1 mission on July 20, 1969. American astronauts Neil Armstrong and Buzz Aldrin became the first people to walk on the moon's surface. Studying the moon is important not just for politics, but also for understanding how planets form and change in our solar system. It helps scientists learn about Earth's history too. Plus, the moon could be a starting point for future missions to explore the rest of space culturally. It has fascinated people for ages, inspiring stories, myths, and art. Renowned astronaut Buzz Aldrin recently shared his insights about the mysterious side of the moon, based on his experiences during the Apollo 11 mission. Aldrin, one of the first humans to land on the moon in 1969, provided unique perspectives on its unexplored region, highlighting the challenges and wonders of lunar exploration. His account offers a first-hand look at the captivating landscapes and geological features of this untamed lunar territory. Born as Edwin Eugene Aldrin Jr. on January 20, 1930, Buzz Aldrin is widely recognized for his roles as an astronaut engineer and fighter pilot. His notable achievements include conducting 3 spacewalks during the Gemini 12 mission in 1966 and serving as the lunar module Eagle pilot during the historic Apollo 11 mission, where he became the second person to walk on the moon. Aldrin's academic journey began with excellence at the United States Military Academy at West Point, where he graduated third in his class of 1951 with a degree in mechanical engineering. He then served as a jet fighter pilot in the United States Air Force during the Korean War, completing 66 combat missions and earning recognition for downing 2 MiG-15 aircraft. Aldrin's academic pursuits continued as he obtained a Doctor of Science degree in astronautics from MIT, becoming the first astronaut with a doctoral degree. However, it was his role as a NASA astronaut that solidified his place in history, earning him the nickname Buzz. This iconic name has even inspired fictional characters like Buzz Lightyear from the Toy Story franchise. After an esteemed career at NASA, Aldrin became commandant at the U.S. Air Force Test Pilot School until he retired in 1972 after 21 years of service. He's been a strong advocate for space exploration, especially for a human mission to Mars. Aldrin also created the Aldrin Cycler, a space route that makes traveling to Mars more efficient in terms of time and fuel. His significant contributions to space exploration earned him honors like the Presidential Medal of Freedom in 1969. However, his success didn't come easily. Initially rejected due to lacking test pilot experience, Aldrin reapplied when NASA changed their criteria, requiring either test pilot experience or 1,000 hours of jet aircraft flying time. With over 2,500 flying hours, including 2,200 in jets. Aldrin exceeded the qualifications and was selected as one of NASA's astronaut group. 3 members in October 1963. Aldrin's role in the Gemini program solidified his importance in space exploration. Initially a backup crew member for Gemini 10, he and Jim Lovell were promoted to the prime crew after the tragic deaths of the original crew in an air crash. This unexpected change thrust Aldrin into a leadership role, leading to his significant contributions to space missions during Gemini 12, launched on November 11, 1966. Aldrin achieved various milestones, including successful rendezvous dock maneuvers and multiple EVA setting records and contributing significantly to scientific goals. This paved the way for his role as lunar module pilot in the Apollo 11 mission, marking a milestone in American space exploration. On July 16, 1969, about 1 million people watch. The big launch of Apollo 11 from different spots near Cape Canaveral, Florida, it was shown live on TV in 33 countries, and about 25 million Americans tuned in, making it a huge moment in space exploration history. Apollo 11 took off at 13:32, Coordinated Universal Time from Launch Complex 9 at Kennedy Space Center, going into Earth's orbit 12 minutes later. Then it started heading towards the moon, after circling Earth once and a half times using its SOVB third stage engine. By July 19th, Apollo 11 got behind the moon and fired its engine to get into lunar orbit. During about 30 orbits, the crew saw where they were going to land in the southern Sea of Tranquility on the next day. Aldrin and Armstrong got into the lunar mod UAL called Eagle and prepared to land on the moon at 1744. The Eagle separated from the Kalia, the main part of Apollo 11. Aldrin gave important navigation data to Armstrong as they descended to the moon's surface during the landing. The lunar module's computer had some problems, so Armstrong had to land manually with very little fuel. They landed on July 20th. Aldrin, who was also a Presbyterian, elder, had a religious ceremony on the moon, which was a first in space exploration. After that, they prepared for a spacewalk, and Aldrin stepped onto the moon on July 21st, 19 minutes after Armstrong, making them the first people to walk on the moon. They set up the lunar flag assembly, did experiments, and talked to President Nixon before leaving. They also did checks and set up scientific tools like a seismometer and a laser reflector as Armstrong explored a nearby crater. Aldrin started taking a sample from the moon's surface. They carefully lifted lunar material in film boxes to the hatch, using a pulley. After transferring everything to the lunar module's life support system, they got rid of unnecessary equipment, closed the hatch, and rested. Then they took off in Eagle's ascent stage to meet up with Collins aboard Columbia in lunar orbit. Once they met, they left the ascent stage in lunar orbit, and Columbia began heading back to Earth. They splashed down in the Pacific Ocean east of Wake Island on July 24th, after a total mission time of 195 hours, 18 minutes, and 35 seconds after Apollo 11. Aldrin continued with space-related work and helped design the space shuttle. When the Apollo program ended, he went back to the Air Force in 1971. During his time at NASA, Aldrin spent 289 hours, 9 hours and 53 minutes in space, with 7 hours and 52 minutes doing extravehicular activities. He mentioned observing the far side of the moon during the Apollo mission. Even though he didn't land there, astronauts like him had the chance to see it while orbiting the moon. His description of the far side as a magnificent desolation captures its stark, barren, and impressive nature, even though it receives sunlight like the near side. The far side lacks the dark Maria or plain seen on the near side, and is instead rugged with many impact craters and mountains. The far side of the moon undergoes significant temperature changes during its roughly 2-week long lunar day. Temperatures can rise to 127 degrees Celsius or 260 degrees Fahrenheit, hot enough to melt certain metals due to direct exposure to sunlight. Conversely, during its 2-week-long lunar night, temperatures drop sharply to minus 173 degrees Celsius or minus 280 degrees Fahrenheit, freezing most substances because of the absence of atmospheric insulation. This lunar region resembles desolate landscapes found on other celestial bodies like Mercury and Callisto. Notably, it features one of the solar system's largest craters, the South Pole Atkin Basin, measuring about 2,500 kilometers, 1,600 meters in diameter, and positioned near the moon's south pole. Historically, exploration of the far side has been limited. However, around 18% of it can be sporadically seen from Earth due to libration, a slight rocking or wobbling of the moon during its orbit around Earth, allowing observers on Earth to view different parts of the moon's surface over time. Despite its synchronized rotation and orbit, vibration occurs due to changes in the moon's orbital speed and the angle of its axis, allowing us to see a part of the moon's far side from Earth. The remaining 82% was unseen until October 1959, when the Soviet probe Luna 3 took the first photos of the far side revealing new terrain. These images, along with data from other Soviet missions, led to the first atlas of the far side published by the USSR Academy of Sciences in November 1960, cataloging 500 features and offering valuable insights further. Soviet missions like Zone 3 in 1965 revealed more details, including extensive crater chains. The second part of the atlas of the far side of the moon, based on Zond 3 data, expanded the catalog to 4,000 features. NASA's Ranger 4 probe was the first American mission to reach the far side in April 1962, but it didn't return scientific data. The American Lunar Orbiter program from 1966 to, in 1966-1967, conducted the first thorough mapping survey of the far side, giving detailed imagery human eyes first saw. The far side during Apollo 8 in December 1968, subsequent missions and probes documented more of its surface. Despite communication interruptions, proposals to land on the far side faced challenges, but recent advancements like China's Quick Yao relay satellite in 2018 improved communication. On January 3, 2019. Chong 4 achieved the first soft landing on the far side equipped with advanced scientific tools for groundbreaking research. One significant discovery was the detailed mapping of material ejected from the moon, achieved by analyzing its internal structure using the lunar penetrating radar aboard the U-22 rover. This exploration helped reveal the geological past of the moon's far side, giving valuable insights into how the moon formed and evolved. The mission also expanded our understanding of lunar geology, laying the groundwork for future scientific studies. And potential moon mission scientists suggest placing a large radio telescope on the far side to take advantage of its natural shield against radio signals from Earth, which would greatly enhance astronomical observations. And research. The term dark side of the moon refers to the unknown nature of this region before exploration. Despite receiving similar sunlight as the near side, factors like Earth shine and lunar eclipses can affect light balance. Furthermore, the term dark also refers to communication challenges with spacecraft on the far side, as direct radio contact with Earth is blocked. The Farid's radio quiet environment makes it ideal for radio astronomy, making it suitable for placing radio telescopes like those in bowl-shaped craters or the Daedalus crater. These natural features offer opportunities for both fixed and large-scale telescopes, improving astronomer ability to study the universe without disruptions. To fully utilize radio telescopes on the far side of the moon, we must tackle challenges such as lunar dust contamination, protection from solar flares, and shielding against other radio sources to ensure their effectiveness in capturing distant signals. However, these challenges are surmountable with time and careful planning. Future missions are being proposed with great ambition, such as deploying a robotic observatory like the Lunar Surface Electromagnetics Experiment lander to measure electromagnetic waves from the early universe. Furthermore, the far side presents opportunities for resource exploration and potential lunar settlement, particularly in its Maria regions, which are shielded from the solar wind by Earth and believed to contain high concentrations of helium. 3. A valuable isotope for fusion reactors. This opens doors for sustainable energy production and encourages the establishment of lunar bases for resource extraction and research. Nevertheless, significant hurdles remain. The extreme temperature fluctuations pose considerable challenges for lunar exploration and settlement. Spacecraft habitats and infrastructure must be designed to withstand these variations to ensure safety and functionality. Additionally, energy-efficient heating and cooling systems are crucial to maintaining suitable living conditions for astronauts and settlers. Despite these difficulties, the potential benefits of these endeavors are substantial. Thorium, a type of radioactive material that can be used as fuel for nuclear reactions, has been found on the side of the moon, facing away from Earth. For instance, there's a place called the Compton-Belovich thorium anomaly on that far side of the moon, where there's a lot of thorium gathered in one spot. Scientists and researchers are especially interested in this because it helps them understand what the moon is made of and how it formed. Thorium is often found in areas on the moon where there are big flat basins called lunar May basins, and places where asteroids hit, leaving craters. It's thought that volcanoes or asteroid impacts brought the thorium up to the surface. This discovery is exciting because it could mean using thorium for power in future moon missions. And when people start living there, thorium is seen as a good option for fuel. Because there's a lot of it, it makes less radioactive waste, and it's not as likely to be used for making weapons. Using thorium could give a steady and sustainable source of energy for things like making electricity. Heating and moving spacecraft on the moon. Thorium is getting a lot of attention because it could be used as fuel for a type of nuclear reaction called nuclear fusion. This process combines atomic nuclei to release a lot of energy, unlike nuclear fission, which involves splitting atoms. One big advantage of thorium is that there's more of it than uranium, which is what's usually used in nuclear fission reactors. Also, using thorium for nuclear fusion could produce less radioactive waste that stays radioactive for a long time, and it could lower the risk of countries using it to make weapons, even though we're still figuring out how to make thorium-based nuclear fuel work. On a practical level, it's a promising area of research. Once we crack the technical challenges, these reactors could be used to power things like lunar bases, vehicles, and infrastructure on the moon. This kind of energy supply could be continuous and reliable, supporting long-term missions and helping us create permanent settlements on the moon, which right now sounds like something out of a sci-fi story. Speaking of lunar exploration, recent events like India's Chandrayaan-3 mission show that we're just getting started with our adventures on the moon. Chandrayaan-3 launched on 14 July 2012, had a lunar lander, a rover, and a module that got it from Earth's orbit to the moon's orbit. It made history by landing near the lunar South Pole on 23 August 2023, making India the fourth country to land on the moon. This success highlighted India's expertise in space tech and its ambitions to be a major player in space exploration globally. The Chandrayaan-3 mission yielded some fascinating discoveries, one of which was the unexpected temperature differences observed on the moon's surface. Data from the CHASE-D instrument showed a wide temperature range of up to 70 degrees Celsius near the surface, challenging previous predictions. Furthermore, the mission identified sulfur on the lunar surface near the South Pole, a groundbreaking find made possible by the laser-induced breakdown spectroscope instrument on the Pragyan rover. It also detected a range of other elements, including aluminum, calcium iron, chromium, titanium, manganese, silicon, and oxygen. Additionally, ASRO, India's space agency, shared plasma density data that gave us a glimpse into the plasma environment close to the surface. The mission also conducted seismic measurements, capturing vibrations from rover movements and a likely moonquake akin to an earthquake. These findings have significantly enhanced our understanding of the moon's surface composition, thermal properties, and geophysical attributes, laying a solid foundation for future lunar exploration missions. The historical competition in space between the US and Soviet space agencies marked a significant moment in human history. Our journey toward becoming a spacefaring civilization might not be as far off as we once thought, with the potential for humans to live in distant parts of the universe, starting with the moon. Although the US and Russia were the first to explore the moon, many countries from Europe, Asia, the Middle East, and the South Pacific are now actively involved in lunar exploration. It's interesting to note that only 12 individuals have had the honor of walking on the moon, all of whom are American astronauts from the Apollo missions between 1969 and 1972. Surprisingly, this number hasn't changed for over 50 years, making these Apollo-era astronauts an exclusive group. Despite advancements in space exploration and global interest, no one has returned to the moon since the last Apollo mission in 1972. However, this might change soon. China, for instance, has become a key player in lunar exploration, achieving significant milestones, with missions like Chang'e-3 in 2013 and Chang'e-4, which landed on the far side of the moon in 2019. China's upcoming Chang'e-6 mission plans to collect samples from the far side, and they openly aim to send astronauts to the moon by 2030. Furthermore, lunar exploration isn't limited to government space agencies anymore. Private companies in the US, India, Australia, and elsewhere are developing technology for lunar exploration, aiming to benefit from the growing interest in space, as multiple nations and commercial entities join in the moon exploration race. There's a promising future ahead, Establishing a lunar economy focused on research innovation and resource utilization could open up vast opportunities for space exploration with continued investments in lunar missions. The next phase of space exploration looks to be collaborative and full of potential advancements. Thank you for watching another episode of Voyager while you are still here. Click the video on your screen to see more mind-blowing videos like this one.